that still don't have, people that don't have yet the concept of what AI is and the difficulty, it might look like a little hard, but as we go along, you will be knowledge. To remind you a little bit, oh, well, let me open one more. I'll open this one. What we were kind of focusing, it's on this example, and I spent quite some time on it. I haven't dived to the heart of it, and that's what we're going to do today. But the concept of interactions, it's one important thing in AI. And here is the implemented and reinforcement learning. Reinforcement learning, we talked about last time. We have an agent that's trying to do something. An agent could be a robot. By the way, it could be a trader in the stock market, somebody trying to invest, and he wants to, his decision is to buy or sell stocks. A robot is really, or even driving cars, as we said before, it's somebody, the car is the agent, making a right, left, depends on the traffic signs or the situation of the roads, could be an agent, and the environment here is the road. It could be the economics of a country. So there is endless examples. This example, the beauty of it is it's relatively simple. It deals with all the interaction we talked about last time, and I'm going to finally talk specifically on number 3 or 4, which we kind of stopped last time. I talked about it last time, but I promise I will go over it one more time. Okay, remind you, when we are in this example, our goal is, if we are in this spot, we want to reach this point, but in the shortest way, meaning I would like to go in such a way that will be the shortest. So if I'm already in this place, I do not want to go up because that will make it the longest one. How do I do it? And the beauty of it, that this algorithm of AI, it will be extended in the future. We'll see more advanced examples like this one, the reinforcement learning DQ. This looks like simpler, but it's in fact a little more advanced. This one is even much more advanced, and here we'll combine convolution. Here we'll take the state, not only a specific place, it will be the whole picture. And I will add one more to real advanced. We might cover it. We'll see. If you request, I will be more than happy to. I'm building it up for you. It's called recurrent reinforcement learning. But you will see that all of them, based on the idea of agent, environment, learning from the environment, taking an actions, valuing valuing every action to every state we are in. That's the heart of this algorithm. And the rest, all the advanced example is how you define the state, which actions you can, and which algorithm can help you to take the best action. So let's finally dive into the heart of this algorithm. Remind you, by the way, I don't know if you already have registered or you're looking for study JavaScript. I intentionally put this example, all of this example of number 3 here is all JavaScript. And JavaScript, it's a very powerful language. Strongly recommend go and study. Okay, will help you big time. The next example, like number 7, we will use Python. And then just the presentation will be with JavaScript. All the rest, this one gives you a lot of much more powerful tools, but JavaScript is an extremely beautiful language. So let's go back to our case and let's go over the code. In Academy City, we developed this framework that you can really organize all your code in JavaScript in an easy way. For example, we want to define the agent. So we'll make a class, okay, in JavaScript. For example, here we have the agent. I will go and cover it in a second. And here we have the environment. Both of them are defined inside a constructor of a bigger object. I won't get into it, but God willing, in the future, and you can ask Brenda and Opio, they will be more than happy to cover those stuff for you. But we built an object, here I call it Mesh.js, and inside the constructor, I'm building those two classes. Class of environment. I went over that last time, I'm just reviewing it, okay? And we have a class for agent. Everything that the agent does and his interaction with the environment, they are all programmed right here. So there are two objects, agent and environment. Just for you, you will see, we're doing it here in JavaScript. You will see in the future and the other cases, okay, let me just show you one more case, okay? We will have very similar, just this one done in Python. Here we have an agent. You can see here the agent. And then we have the environment. Okay? The environment and the agent. And their structure is very similar. The only difference is that the model is a little more complex. And here we will, for example, we're defining the models and the whole things and the estimation that we use. Okay, the model that does, instead of the Q table that we're going to cover today, we will use a model a little more sophisticated, but the structure is extremely similar. Okay, so learning this example, it's a very good foundation for you for the future. And you will see, you can make a career just learning reinforcement. And you extend, we'll talk about recurrent neural network, we'll talk about convolutions, and you will see you can add it to this algorithm and use it, make a career. Yesterday, I was in a conference, a very good conference here in Israel on AI. And there were a lot of young guys, which made me very happy to see the beautiful stuff they're doing, utilizing this technology. I hope one day to see it there in Uganda and see you guys doing the same things, okay? Okay, back to our stuff. Environment. What do we have in this environment? Okay, we have this picture. Okay, by the way, this picture, it's defined right here in the code in the very bottom. Here we go, look at that one. You see, this one, it's an array of 2 dimensions. Okay, everywhere you see a 0, it's an empty place. Every place you see the 1, you have a wall. That's a place that the agent cannot walk into there. Okay, the agent is going to start from the beginning, and he's trying to get to the end, and it can go only into the places that it's 0. If you hit a 1, it cannot walk into there. So first of all, we're defining the picture of the environment, okay? Now, the environment has to give rules to the edges where it can go. It cannot go to the wall. So those kind of things we will see in the definition of the objects. Excuse me, I'm really going to be technical today. You cannot really avoid it. You know, some people like to be managers of AI. Take my word for it. They usually fail in the future. You really have to dive and learn the programming and be extremely good. Okay, by the way, here we go. The environment, if you see, the first things we do, we're transferring this maze. We call it maze, commonly known. So this is really the definition of the structure. We are building up here in the bottom here, if you have a good eye, we're making this. This is, if you know, this is the way you create an object in JavaScript. And the first things we're transferring to him, it's this structure that we just defined right here. So we're building up this dot if. This is really making the if to be a parameter that hold the environment, the class environment, the specific object of environment inside this general object that we call Mesh.js. And the whole thing is managed automatically for you. But here, what you do, you're creating an environment, okay? And in the environment, I tell him, where do I want him to begin and where I want the end? Meaning, after you're getting this structure, mark, okay, the beginning, the start, you can see it's 0, 0, meaning it's right here. And then you have 9, 9, that means the end. By the way, remember I mentioned last time, we're counting from 0 to 9, not from 1 to 10. Very common in good languages like Python, JavaScript, and many other languages. Okay, so 0, 0 means the first one, 9, 9 means the last one. Everywhere that it's 0 here in that array, two-dimension array, it's a place you can walk. The agent will be able to walk. Everywhere it has a 1, it will not be able to walk into there. Okay, beautiful. So this is basically building up the environment. In this picture, this is this part. Now we want to look, let's just look at the functions that we have in the environment, okay? What kind of things we have in the environment? By the way, one thing is, if the agent is already in a specific cell and it takes an action, for example, if he's already here, okay, and he makes an action to go to the right, so this function basically change his place. It's just saying, okay, from XX, let's say I'm here, and you're making a right, so it will change from this X, from this one and this one, it will move it to be this place. That's really all what it does here. The other thing is it makes sure that if you try to walk, for example, if you are here in the beginning and you make a left, it will say, oh, you cannot go back, and then it will keep you in the same place. That's really what this function does. Please, I will say it's many times, please go over this code 10 times, learn it by heart, understand the structure. It repeats itself in many more advanced stuff, so it'll be easier for you in the future. So this function basically moving the agent, if he takes an action, if he's in a specific place and he's moving to the right or to the left, it will move his X and Y places. Okay, this is what this one does. Next, which we talked about last time, if the agents hit a wall, okay, if he hits a wall, it's a bad signal. And we want to give him a signal, don't go there again, because otherwise you will penalize. And this function telling him how much we penalize him or we're rewarding him on good actions. In other words, let's look at the code here a little bit. Let me make it bigger so you can see it. Okay. If the agent get to the end and successfully reach the goal, you will get a big bonus. You will get 100 points. Okay, that's a good signal to the player. So, oh, that's really what I wanted to get. On the other hand, if he hit a wall, meaning one of those black places, then we penalize him and give him a negative reward. Then he knows, oh, I don't get hit. If I went there, I keep a record of my behavior in the past, I'm not going to go there again. On the other hand, if he just walk around, and this is, you can ask why I'm penalizing him. If he takes an action, a good action, in fact, even a good one, okay, he just walk, let's say, from this place to this place, it looks like a good one, but I'm penalizing him. Why am I penalizing? But I'm penalizing him a little bit. Why? So he will not go into the longer route. Because if he's here, I really want him to go here. Don't go here. Because if he goes here, he's just wasting steps. I don't want him to do that. And if he realizes, as he's studying the environment and he's studying the behavior, if he realizing he's penalizing by going up, he will not do it in the future. So in the learning process, he will do just to learn, and then he will go back. And the next time he's trying again, he's not going to go there. Okay. So that's the reason why we're penalizing with -1 here. So this is the reward, the environment telling the player, the agent, what will happen if he takes specific action. Okay. Now, the next one is just really a helping function to tell, did I arrive to the end or I didn't arrive to the end? So those are basically the functions of the environment. Let's go and look at the agent now. What the agent does, okay, first of all, let me divide it. There is, it can take an actions and all of that stuff, but I would like to, first of all, get the environment so he knows what the environment is playing inside. So we're giving him the environment. So he knows and he's going to learn about the environment and deal with the environment and activating those functions. Is interacting with the environment. That's the topic of today. We're going to talk about those parameters. They are really the parameters that helping the agents to learn about the environment and the speed of learning and the concept of exploit versus exploring. We'll talk about those one heavily today. That really is the topic of today. I'll get to them. But one concept I mentioned last time, I haven't described it quite well last time, it's the Q table. We said Q table is really taking this table and every cell inside the table, we're going to value. We're going to value not only the cell itself, the cell for any action I'm taking. And that's what we call the Q table. We start with a dictionary. And then we initialize the Q table. This is a very important concept because we really know nothing. When we're starting this game, when the agent starts studying, we know nothing about the game. So we will start by saying we don't know anything. So this initialization function does this one. And this one basically putting 100 rows, or you can say 100 mini dictionaries, and in each dictionary, we're putting those 4 actions that I can take in every cell. So every cell here, I can have 4 actions. Let's say if I'm here, I can go up, I can go right, I can go left, I can go down. In the beginning, I don't really know anything about it. So I am valuing them as the value of every action for this specific cell, it's 0. So I know nothing. That's really what it means, initializing the Q table, knowing nothing in the very beginning. And the real learning is, as I'm playing the game, as the agent is playing the game, to learn about those states and to learn what the value of every action for every state, that's the goal. And then after I know the value, I can really go and find the shortest path. So this is, first of all, initializing that I know nothing about any action that I'm doing. Now, we have another function, which is a very important one. This is almost in every algorithm has the same logic. And let me explain. Some of them a little more sophisticated in changing the epsilon parameters. And I will explain. You can see this function in the future. Okay, I hope you will be able to download this code and look at it. You will see that we have here I think I called it an act. Let me see that. I think it's act I called it. Let me see. I just want to convince you that this function is and the structure is very similar. Let me see if I can. Here we go. You can see the structure, it takes this epsilon, it takes the state, okay? And it has 2 parts. The first part is what we call the random part, okay? This is the random part, okay? And this one is choosing the best action, or the action that choose the best action. We talked about what is argmax. I'll go over it one more time. This is done in Python. This is done in JavaScript. The logic is very similar. And it's very similar in almost all those reinforcement, sophisticated real-life examples, or real-life projects, I should say. What do we have here? One concept is explore, and one called exploit. When I'm starting to learn about this game, and you'll see when we look at the loop of learning, okay, I know nothing. And if I don't know nothing, if I'm here, I really don't know, should I go right? Should I go up? Should I go left? I don't really know even that up, I would hate the wall of the game, or going down, I would hate. So in the beginning, I'm usually explore. Explore means let's take some random action. Let's take some random action. You know, if I'm here, maybe I will make right. Maybe I will make down. And I will see by the results what the environment will tell me. If I'm hitting the wall, I will get a negative reward and I will not go there again in the next time. So in the beginning, we're exploring. What happened? Who was
Okay, I
there?
think someone has a question.
Yeah, go ahead.
It's Noah. I see he has raised his hand up.
But let me finish that. I will answer question later on. Yeah,
Okay.
I won't get the whole material, but I will be more than happy in the end. I will answer questions. Okay. Thank you, guys. Thank you for the patience. Okay, I promise. If we need one more session on this one, I will do one more session. Okay, especially that this is the foundation of reinforcement learning, such an important concept. I will even, if we need, we'll make even one more session. Okay, so this stage, if you notice, we're taking a random number. Random number in JavaScript give you a number between 0 to 1. Okay, and then what is that one? Can you please don't do that? Thank you. Okay, then out of those, I have the action, and I have only 4 actions: right, left, up, and down. Okay, so by multiplying it here,
I think someone is doing something. Shin, is that you?
Okay. Please don't do that. Okay, thank you. Thank you. Okay.
No, I only laughed because it was funny, but I only watched the presentation. Everything is fine.
Okay.
Okay, thank you. All right. So what we're doing here is really taking the left on the action. We have 4 actions, so it should be 0 to 3. We're multiplying it by a number that is less than 1. So the AN will be the action number. It will be any number between 0 to 3. Okay, and that's why we're taking the floor. Okay, so it'll be 0 to 3, 0, 1, 2, 3. And then this action, we basically going to the environment and pulling the action itself. If you go there, you will see there's 4 actions in the environment. Okay, I showed it before, and you can go and see that. So this is really in the very beginning of the game, we're taking a random action. What happened later on, this epsilon will go down and down. You'll see, I will show you the code. That would be a very small number, meaning as the game evolve, we less take a random action. We will take what we know, we call exploiting. We'll exploit our knowledge. And we're going to take an action that yield the highest value. What do I mean by that? If I'm here, okay, going to here, I can go back. I'm not hitting a wall, but it's a waste of a move because I cannot go anywhere here. I will have to go back. Okay, so this one have a much lower value than this one. This one will have a higher value. Moreover, even here, I can go back and then I will have to go return. Okay, so when I'm here, the one that have the highest value probably will be this one.
Sorry.
And
I have a question.
No, please. Question I will answer in the end. Okay, I apologize.
Okay.
I will. I promise I will, and if needed,
Kullert auf dem Boden verspielen?
I will answer question in the end. Okay.
Okay, Alec, macht Spaß. Jo, danke.
Okay, thank you guys. Okay.
Sorry for the disruption.
Okay, the exploit means I'm going to take the actions that have the highest value. Well, how is the value being generated? That's the idea of the Q table. We'll get to the Q table. If you see here, if I already have a good toward the end of the more I'm playing and playing, the Q table will have more values. This one will be updated. Okay. And by the way, this one returning 4 values. This is the dictionary. And out of this dictionary, I will take the action. I will not go over the code here. I will leave it to you guys to study how you take the maximum of a dictionary. But you do have the function here. Go read about it. Okay? Please do. It's a good exercise for you guys. So I will take the action that gave me the highest value in the Q table, something I explained last time. Okay? So in the choose function, one of the very important functions for the agent is the beginning of the game, you usually take a random action. As the game evolves and you learn more about the environment, you take the actions that generate that has the highest value. If I'm here, the one that will have the highest value would be most likely this one. Yeah, because we know that from here, I will continue to the path. But this one will not have a high value. Going back, of course, it doesn't have a high value. So when I'm here, as I'm learning about and I'm generating this Q table, the Q table will tell me, yeah, go to the left, because this one will have the highest value. That's what this function does. Now we're getting to the really hard one. So really, I really excuse me if it would be hard. When I studied it, it was extremely hard for me. It's very hard for most of the students I have taught in the past. Okay, but after you go over it 5, 6, 7, even 10 times, okay, go over it, learn it by heart. Okay, because this is the heart of the reinforcement learning. This part, this is it. Okay, we'll go over it. So what is it really? What is this function? The Q learning. But before I will go into this function, let's see the logic. Why I'm activating this function. So I will kind of jump of it in minutes. I'm coming back to it. Okay, I'm coming back to it. So let's see. This function is the function that actually, you know, when I'm clicking here, this one is activating the start training, and the start training will activate this function. Now, what this function does, it's beautiful. Look at that. I'm telling this function to do, go this number of iterations.
No.
Let's say
No,
500
no,
times.
I
don't
don't
know
no,
how many
no,
times that we.
no.
I think,
No.
Bill, if you could
No.
just
No.
mute everyone, I think would be a good idea. And then I
No.
will give time in the future.
No.
I will give time to everyone to ask
No.
questions.
No.
Okay, thank you. All right. So iteration means play the game. Play the game, let's say 500 times. So you're starting from this point, you try 500 times and you learn. And every time you learn.
Why is Finn Big over Mega Schwul was kicked?
Oh, okay, please. I really would like to say it last time. Esther, can you please mute everyone? I think
Then
that
you can mute them.
you need to wait. You need to wait, please. Okay? You need to wait for the end. And then I will, as I promised before, I will answer questions. I can't really take questions, otherwise everybody will get confused. Okay? Okay, but I will, as I promised, I will take question and I'll give even elaborated answer. Okay? But just bear with me for now. And you have, this is being recorded. We'll upload it to the server. We're uploading it as we did before. All right, so what do we do here? This is what's starting the heart of the algorithm. We're doing, let's say 500 times. Let's say iteration, you can put 1,000. I think we're using 1,000 here. 1,000 times. Play the game 1,000 times and learn from your mistakes. And what does it really do? You can tell this is the code. For loop is going from 1 up to the iteration. If iterations is 1,000, is going to activate the Q learning function. Is going to run Q learning function 1,000 times. Okay. And what does it do every time? So let's go over it slowly. And please focus. And if you don't get it first time, don't be disappointed. Believe me, I didn't understand it first time. I went over it several times until I got it. So what do we do in the Q learning? Stage number 1, we're asking the environment the starting point. We know the starting point is this one. Okay, so it's giving us 0, 0 here. So X and Y will be 0, 0. So we're getting the beginning where the game is starting. What is the next one? Now this is another hard one. This is the first hard one. We have a while loop. This while loop goes all the way up to here. In fact, it's really the most of the stuff. So I'm starting the game. So when I see this iteration, it's really play the game 1,000 times because he's going to get into the game and start playing the game. This is playing a game. So what the game involves? I'm starting from the beginning. the starting point, and I start playing. The first thing that I'm doing, I'm choosing an action. The agent is what action he's taking. The beginning, we said, is random. So he might want to go up or left or down. All of those, he will be disappointed. The environment will not let him go out of the game, or we will hit a wall. He will get a reward negative 10, if you remember. And he's going to document it. We'll see in a minute how we document it. And it will know next time, I'm not going to do that. So here we go. Let's say he went down and he will hit a wall. So if he's hitting a wall, the environment will tell him, get next state. If you remember, that's a function of the environment. If you try to go down, he will tell you, here, you hit a wall. You're not moving back anywhere. It will put him back to the same place. Not only that, his reward will be a negative 10, if you remember. The reward will be a negative 10, and it will not move him. And this is, he's going to learn, he's going to utilize this information and keep it in the Q table. Okay? He's going to keep it in the Q table. And now you can see that how he's going to take this one, so in the future, he's not going to make that mistake. And that was the code in those two parts, which are really the heart. This is the heart of the whole things, okay? So let's take step by step. First of all, we have something called best next action. What this one does, remember, when I try to make a move, if I went down, it will tell me what is the next, where you're going to the next, okay? And then I'm getting a reward. So if you look at here, the first time is trying to take the value of the existing one, okay? Of the existing one. And he's trying to get the one that give me the best from the existing. But the truth of the matter, if you remember when we started the game, we initialized everything with 0. If you remember, we initialized everything with 0. What was that? Here we go. We initialize everything. So really, I'm getting 0. All of them will be the same value, have no value. So when I'm just starting the game, this is really useless for me. We'll see in a minute. This is extremely important. But in the beginning, everything is a 0. So it's really like choosing randomly. Okay? And then, but one thing that does a difference is this one. This one makes a difference. And pay attention, this is really where all those parameters I was talking about them come into place. One, first of all, look at the reward. It's right inside here. Okay? Maybe I'll make it even bigger so you can see. I'm going to focus on this code now. Only things which matter now. Okay, I'm going to focus on this part. Okay, this is really now the heart of it. And I'm going to go over that one when I'm not in the beginning. Okay, so what do we see here? Okay, in the Q table, I want to give a value to the place I'm here. By the way, when I'm starting the game, it's really 0, 0. That's the first one we are starting. What's going to be the value of 0, 0? If I made it to the right, okay, doesn't matter where, it's always will be 0 because the next move, the Q table for the next one is all 0, 0. So this is really, in the beginning, had no value. So this one is all will be 0. I have only the reward. Okay, the only things I really have is the reward. That's really what I have. And okay, the reward, if it is hitting a wall, it will be -10. If it is making to the right, it will be -1. Oh, -1 would be better than -10. -1 is more, it's higher than -10. So the Q table of moving to the right will have -1. Okay, but this -1 is higher than if I went down or I went to the left or up. What happening is after the first round here, if I'm trying all those 4 actions, this one will have -1. this one will have minus 10. This one minus 10, minus 10. So for the next game, remember we're doing it 10,000 times. In the next game, I know that I'm not going to choose anyone by this one because this one has the highest out of all of them. Okay? I hope that's clear. I know it's hard. Okay? And just think about it. In this round, when I started the game, this is just changing the action of going right to be -1 and all the other 3 to be -10 times the alpha. I will ignore the alpha. Alpha usually starts with 1 in the beginning and then you change. Depends. Alpha could be 0.2, could be, let's see how much, what are those parameters? How much we put alpha? Alpha is 0.1, but it really depends on the game. You might change it depending on the game, but 0.1 for this game is perfect. Still, relative importance, that's what the importance. I'm taking -1 times the 0.1, or I'm taking -10 times the 0.1. It will make going to the right will be more valuable. So that's what I'm getting from this part. Okay, let's say I was lucky and I eventually got to this point. Okay, and I will start continue. Next, continue. Remember, this is a while loop. The while continue. I haven't reached the end yet. So from this point, I'm trying to walk again. I'm trying to walk. I can go up. I can go left. Left won't be hard, but I can go back left, but I can go down or back to the right. Again, I can continue with the second one. I will reach to this part. I will most likely will get random, but only one thing is this one. Okay, this one would be -10. This will be the reward will be -10. This one will be -1 times 0.1. It starts building up the value of the surrounding. So now when I'm here, I might get, you know, that this one will have a higher than this one because this one is already -1. Okay, -1 point. This one has a 0. So 0 would be the highest. And it probably will go to the next one because this is have the highest one. In another word, try to play with these two functions and see what happens. Okay, I tell you what I will do. Okay, I tell you what I will do. Might be interesting for you. It would be hard to see. You can look at the whole. No, it's really required more time than we have. So I will maybe leave it for next time or at all, or maybe even let you play with it, okay? And the bottom line of those two is that the game is evolving until you get to the end of the game, okay? Or you hit a wall. If you hit a wall, it will break and then you start the game all over, okay? So this is basically from here to here is playing a game. A game, it's ending if I'm getting to the end or I'm hitting a wall. Okay, if I'm hitting a wall, it will be the end. And then if you have a good eye here, pay attention to this code, epsilon. This epsilon, we are reducing the epsilon, but we're not reducing it to a 0. And how do you know that this is reducing the epsilon? If you look, this epsilon times the decay, what is the decay? If you look at the decay, it's a number between 0 to 1. Okay, so you have the decay. Yeah, here we go. It's 0.995. The reason you use, it's almost 1, but it's not 1. Meaning that this epsilon of 0.1 becomes to be, if I multiply 1, so 1 times, you know, when epsilon is 1, means when we're starting the game, is all random. I always pick up random moves. But after the first game, I'm reducing it to less than 1 because 0.995 times 1 is 0.995. This one is going, this multiplication, going to affect the choose function. If you look at this choose function, the first thing is checking, is the random number I'm picking is less than epsilon. So when the game is starting, that epsilon is 1. But after the first game, we're reducing it. And if I'm reducing it less than 1, I start exploiting, okay? Not always I'll pick random one. I will start using the Q table, as I mentioned before. So epsilon, after every game, is becoming to be small. What does it mean from the choose function? What it really means is that I'm not choosing anymore random toward the end when I'm running 1,000 games. Let's say the last 10 games, it's almost always exploit, but we always leave some level of exploration. And the way we're keeping exploration by this kind of, when you see is the max, we always make it at least it will have this minimum. Don't go down. If you're going down more than this minimum, stop. Don't use it anymore. That's really what it means. By the way, this logic, it's all reinforcement learning. You will see we'll do the same things in Python, in which we're reducing this up. So we might even make it more sophisticated, okay? There's many ways that you handle it. Some people make it like it's jumping, and there's a lot of reasons why they do that, okay? But the idea here is as I play, I learn more about the game. If I'm learning about the game, I don't want to choose randomly that much. I want to use the Q table. And this one is, again, this is really the iteration that we do for every game. In the end of what we're getting in the end of this one, we're getting a good Q table, okay? And this Q table will have different values. I showed it to you, I think, 2 sessions ago without explaining, okay? But now at least you know how the code is structured, and we're getting this Q table. And this Q table is being learned by this function QLearn, okay? And this one we're doing 1,000 times, or the number of iteration, until we are learning. Believe it or not, it's so fast, okay? It's extremely fast. And how do you know that it's so fast? When I'm clicking on this one, it's actually doing this 10,000 times. Let's click on it. Boom. Wow. Look at that. It did the whole learning. It did 1,000 times so quickly. And after it did one, it found that those one has higher values, and that's the way it goes. I leave it to you as an exercise. It's a hard exercise, but believe me, you thank me if you succeed to do it. See, there is a function here called a path. See this path? After the game is being learned, and I know the Q table, out of the Q table, I can tell the agent to be able to know which way to go. Because when he is here, this one will have the highest value. So he will go here. When he is here, this one will have the highest value. He's not going to make mistake anymore. And it will continue. When he is here, he's not going to go to here. It will go down because this one will have the highest value. So this path, basically, this path rolling over the Q table and finding one step at a time to which one should I go. Let me know after you go over this code. If you have a hard time, in any case, I will go over it next time, okay? But I think it will be good for you guys to try to struggle with it. Don't be discouraged if it's hard. Don't, because it is hard, okay? It is hard. But believe me, this code, I try to build it up in such a way it would have the shortest code. You'll see that some code are extremely complex. This one is so condensed, still give you a beautiful example to learn the foundation of this one. So let me summarize, and then I will take questions. Okay, guys, let me summarize. We say in reinforcement learning, we have environment, and we have an agent. The environment tell me if I can move to one place to another in this type of a game, okay? And it tells me the reward I get to any actions I am making, okay? That's why when when the agent takes any action, the environment, see what action the guy is trying to do. It tells him, if you take this action, you're gonna end up in a new place. And also, this is the reward you will get. The agent perceives those two, as we saw before, okay? It takes the reward and he updating his Q table. And the beginning, okay, after he's updating the Q table, he again take another action. If is in the very beginning of the game, he doesn't know much, he takes some random action. The more he plays, the more the Q table is being updated, and then he starts taking more smart actions. And when he takes smart actions, the environment usually will give him a higher reward as versus if he's hitting a wall, okay? And again, this goes around and around. So in the very beginning of the game, the agent's taking actions and is usually use the concept of exploring. That's why the epsilon is high. And as the game playing, it will explore more, it will exploit more the Q table, which tells him which actions are the best one to take. Now, I put some material. Whoever wants to read, they are excellent material. They are a little hard, okay, but you're more than welcome to view them, learn them. They are beautiful examples. But I try to put here in this video as much as we can in the shortest way, okay? Just for yourself, when you're playing, you can play many times, and we did another things here with our framework to make your life easy. If I tried the first time, by the way, this can happen to you. I hope I didn't make a mistake here. Let me see. I hope I didn't destroy anything. You see? Yeah, good. When I click here and you want to play the game again, you can click again here. It will empty everything. You can change the structure. If you click on that once, it will disappear. If you click here, you can disappear. By the way, now, when I click this one, it will do again 1,000 times the game, and it will find something else. Here, probably will find a different shortest line. Let's try it. Click here. Oh, beautiful. It's not going to go the way it did before. He's going to a different way because he played the game 1,000 times behind the screen, and he built up the Q table, and based on that Q table, he found in the path function, which I did not explain, I give it to you as an exercise, he found a shortest path. Okay, I stop here. I give you to ask questions. I'll be more than happy to answer questions. And if we have time, I will maybe elaborate on, okay? So I'm ready for questions, guys. Opio, Ezio, why don't you let people open their microphone? Anybody, questions? I'm more than happy now to answer questions. Anyone? Nobody has questions? Ah.
Hello, good evening.
Good evening.
My name is Ivan. Yes, I have a question about the Q table. I'm trying to understand the kind of data structure. Is it having a data structure similar to the environment? And I'm trying to understand exactly what it's storing. Does it store just the value of a certain, let's say, position, a certain action that's taken, or it stores both the value and the value of an action, and then the kind of heuristic value towards the goal for that? So does it store two values?
Let me go step by step. The structure of the Q table. By the way, your question is good. It's structured good. You're saying, does it have the same as the environment? The answer is yes. It's mimicking the states of the environment. What are the states in this environment? It really is all those 100 cells in the game. So the Q table has 100 states, but for every state, it has 4 options, which are the actions. So to give you a complete answer, you know what I will do? I will open the code for that. Yeah, I like this question. This is a good question. Let's open and see how it looks like, okay? let's do the initialization. We're having the agent. That's what I recommend you guys do. And Opio and Brenda could give classes on that, on learning how this code goes. Let's look at the initialization in here, okay? After I initialize this Q table, let's look at it, okay? And see the structure. By the way, this is really the way you should learn. Ask those questions yourself and then go to the code and explore them. Here, I'm going to see the structure of the Q table. This is one of the most important ones. Okay, I'm going to run it and look at how it looks like. But I'll do it twice, maybe. I think I did it once, but I'll do it again. It's worth it. Let me refresh. I didn't like me. I knew that. Hold a second. I'll do it. I need just to do stringify, but you won't be able to. You will see it as an. You will see it as an. You will see it as an object, and not as the way you usually see stuff. So in 1 sec, I'll just use stringify here. There we go. That was me. We will be able to this is where you will be able to see the stringify. You will see it as a string and not as an object. Okay, beautiful. Let's refresh. And here we go. What is the structure? Pay attention. You have 0, 0 is the first cell. For the first cell, you have dictionary that have all the 4 options, which is up, down, right, and left. For the second cell, 0, 1, this is like the index of the second cell, same things. And as we're initializing everything to be 0. Fair enough? That's the structure. You already have a 99 of them, okay? You will see this is the index of each one of them. So you can tell it's 100 by 400 places, which is the environment and action. So if you really want a complete answer, is the Q table is 100 by 4. That's what the table is. Let me now show the same one by the end of the training. How about that? Let's take the same things when it finishes the training. So let's go bottom here. We're doing it 1,000 times. Is that right? Let's see how does it look like after I run it 1,000 times. Let's see the structure field. Here we'll see data. Okay, let's try it. Let's refresh. Here everything's 0 when we initialize. Let's go there. We'll go to here and we activate. Let's run. It's run. Oh, here we go. Look at the beauty. From 0, 0, 0, 4 times for each one of them. See the value for the 0, 0, which is the first cell. First cell, if you go up, you get a negative number, -7 point something. If you go down, it's even more negative because this is hitting a wall. Remember, hitting a wall, it will have much more negative. Going to the left is also negative. So going down is negative, going left is negative, going up is negative. If you look going to the right, it's a positive number. You see that? 1.965. Okay, it does it 1,000 times until you're really valuing every space. So for this, the Q table, for the first cell, it's the index 0, 0. And for this 0, 0, it has a dictionary with a value for every action. Now you understand why I gave you that path. You know, if you really want to do that, learning that function, it will loop over all of them, one to the other one, and you always move from this place, it's going to move only to the right because the right will have the highest value. So it's not going to go up, not left, not down, because all of them has negative numbers, and going to the right is positive. When I'm going to the second one, you can tell already the second one is 0, 1. When I'm here, which place should I go? I really should go here. Let's see. Okay. Going up is negative. Going down is negative. Going left is negative. Going right is positive. So also when I'm here, the only one that has a positive one is going to the right. Now you see why the edges now know how to go. It follow this Q table. So the question is beautiful question. Okay, I hope that answered. Any more question, guys? Don't be shy, okay? There is no stupid question. Take my word for it. After so many years that I have been teaching in the university, I never had a stupid question. But I do know that some people shy. They think they are the only one that don't understand. Believe me, at least half have a hard time, especially first time listening or learning this kind of material. So don't be shy and go over this video several times. And if you have questions, don't be shy. You can send it to Opio and Brenda, and I'll be more than happy to get those questions and answer them and send it back to you guys. Anyone, any more before we conclude?
Yeah, there's another question. Caesar
Yeah, go
is
ahead.
asking.
Yeah, thank you very much. How does after the Q table has been updated, how does the find path get activated, and how does it go through the Q table? Thank you.
Beautiful. That's the exercise I gave you. And I gave you the answer, but I would like you to go and try to figure out yourself. If you go here, there is a function. There is a function. Let me take those ones so I don't really get, you know, when you put it here, you can see really how it's being updated after this 1,000 times. This is the way it starts. And if you look at this function path, okay, I will go over that a little bit, okay? Okay, if you see, it's starting from the beginning, okay? Start from this one, and then it starts going from, as long as X and Y is not the end, it's not the end, it does the following. It takes an action, it is choosing something, okay? From X and Y, okay? And then is activating by taking, you know, when the Q table is already educated or filled, remember the find path, it's after the Q table is already filled, like the one that I showed you with the positive places and negative. This one will definitely tell me from the first one, I will go to the right because only the right has a positive number. So this action will tell me go to the right. And then this one will move me to the right. Fair enough? Got it? And then it goes again. And then I'm pushing. By the way, this one tells me I'm starting with the path to be an empty one. Where is the path? What did I define it? Here we go. Let me just find it. Here we go. Yeah, if you have if you see the way we define the path, it's from the beginning. Okay, this is what we're starting. Okay, and then what I do is I do a loop until I'm getting to the end, as it does here, and then I take an action. And the action, since the Q table is already filled with the right numbers, this one will return from the beginning. It will give me this one. And this one, when I'm finding it, or what I do, I push it inside there into this page. And you go around and around until you get to the end, and that's the way you found the page. But please, please, don't just listen to me. Go and do it yourself. This is a beautiful code. The next question, you said, okay, you found the page. How do you paint it? okay? And by the way, you can see there are other function here that we did. I think it's the display. This is the display. You can go over that. It's not a simple function, but it shows you how you paint the structure. This is a JavaScript. It's a pure, but this is not really, the beauty is taking the structure, but that's not special for reinforcement. It's just a beautiful way of painting on the screen using JavaScript. And it's a really nice, this is a really nice function. I spent some time to make it elegant and efficient. You can do it many ways, but it won't be efficient. This one is a very efficient way of doing it. So this is a good one for you. Just follow it up, okay? Because not only that is following the path. Let me just make sure. No, this is change. This function is when I click here, you see, this function is being activated, allowing you to do that and painting it here. The display basically showing the whole things and places of the page. So this, okay. More questions, guys? Okay, beautiful. I'm trying to keep it within an hour, but I will dedicate some more time next time before I move to the next topic. I'm debating, I might jump to number 7. No, I will go, maybe next time we'll go over that again. It's really worth going over the same things over and over. Whoever know me, I usually like to repeat myself many times in the beginning. And then when you really have a good understanding, you can move faster. And after that, we will jump to number 7. This one, it's more visions and face recognition, which is a beautiful topic. But I think I will jump a little bit to this one. This one has, let me just refresh that. We'll jump to number 7. To some of you, it might be a little difficult, but it's open up the road to neural networks, which is used internally also by those ones. Okay, so those ones using also neural network. This is a beautiful of converting the Q table into a function. So that would be another jump in the difficulty level. But whoever get those two, you really have done a hell of a lot. Knowing those two, you really are in a good shape. This one will take the function, the neural network, to be a little more sophisticated function. It has 2 layers of neural networks. But I will dedicate at least 2 sessions on this one. So I will do a review next time of this one and start talking about neural network, but at least explaining the move from a table into a function. It's not a trivial exercise for students. Okay, guys, thank you very much. See you next week. Good luck. Please go